G'day. This clip is about my Waldown drill press. For those not in Australia, Waldown is a quite respected name in drill presses. A second-hand one is keenly sought after because they're a nice solid drill press. This one was built This one came from an old welding shop, and I had to replace the motor because they ran the belt tension too high and managed to snap the motor shaft. But apart from that, I've had to spend very little money on it. I've fitted a light to it. However, one thing that's always annoyed me about it is the speed range. The speed range goes from 650 RPM to 1800 RPM, and there's a gap in the middle. And so that gap happens to be where I do most of my, or would like to do most of my drilling, and so I thought, okay, let's see if we can do something to fix that. The inside, it's a 9-speed drill press, and the inside runs on V-belts, and it's one of those ones where you have a choice of 4 here and 3 here, but because one of these uses the same pulley as the spindle drive, you really only have 9 speeds. And that's the second thing wrong with it, is that the belt length, and I'm not being critical because this was designed way before computers made this sort of stuff easy, the belt length isn't quite right in that sometimes there's a little bit more slack than others. And so I've put together a spreadsheet. It's gone and looked at the centre distances, looked at the ratios that I want, all that sort of stuff, worked out what the belt lengths need to be, and so now I'm making up some pulleys to suit. And the first one I'm doing is for the motor. I'll then be doing for the spindle, and then the third one, because it's the more complicated, for the intermediate, I'll be doing possibly in another video. We'll see how we go for time on this one. But instead of using A series V-belts like this, I'll be using these things, which are they're a poly V belt. This is a J series, and with this I should be able to get a more compact drive, as well as getting the speeds and utility that I'm looking for. So it should be interesting. While I remember, a bit of a shout out to Cryan, who managed to find the lumps of aluminium billet for me to do this. He knows of a guy who's got a few offcuts and got them at a good price for me. And another shout out to Eric, who was able to slice some pieces off and trim them back down to size. So thanks to both of those guys, this project probably wouldn't have happened without them. This is a J series poly V-belt. I don't know how well the camera's going to pick it up, but it's basically a whole bunch of V-belts, or small V-belts, crammed into one belt. They're quite flexible. You can actually tension them on the back, which you shouldn't do with a V-belt. And these are what I'm going to be using to drive the drill press. I'm just about to grind up the grooving tool for my multi-V pulleys. And to start, I've roughed out the blank. There's a bit of tool steel, but I've roughed it out with an angle grinder to give myself what would you call it, a smaller tool, or smaller tip, around about 4mm wide. And the reason for that is that when I cut these things, I don't know how easy that is to see, I'm going to be trying to get right up against the shoulder so I can get a nice compact sheave. And so this is going to be pretty much done for minimum clearance on the back of the belt. Here is my ground tool. I'm setting it up with the old steel rule trick, and that is, if the steel rule is vertical, the tool is pinching the steel rule onto round stock, just on centre height, and that's close enough. What I want to do here, sorry, the camera landscape just caught. What I want to do here is just do two things. One is put a very slight cut on the bar stock, so I can see what the tip width is like. And the other one is I want to then do a slightly deeper cut and just see how the J series poly V belt sits. This is looking good enough that I'm seriously considering not touching it anymore. You can't see it here, I've just tried, but a smidge of daylight underneath the V's, so the tip width and the depth that I'm going to, which was the other reason for trying this, should look like they're going to be pretty much spot on. The first pulley I'm going to do is the motor pulley, partly because it's pretty straightforward and it'll give me a chance to get my eye in, but secondly, I'm going to be using that to establish the levels of all the other pulleys. So I've set up my stock. I've had to slide the tool post back to its rear position, so I've got enough travel there. So we'll see how that goes. But the first cut I'm going to do is just basically face that off and true up that diameter. Once I've done that, I'm going to flip it over, face it down to size, finish truing up that diameter, and put the hole in there for the mandrel. I do that because I'm not sure how square either of these sides are to the diameter, and so by squaring that up and then seating that against the chuck, I've got a better chance of getting that bore square to that face. Stage 1 done. I've got that surface faced. I've got this diameter down to close to my finished size for the sheave, the pulley. I can now flip that around in the chuck and know that if I'm up against that surface will be perpendicular to it, and if I face that off with that firmly in the chuck, I'll be parallel, which is what I want. I'm now down to very close to final diameter. I'm right for thickness. I've put a pilot hole for the bore of the motor through there. I'm now going to bore it out. Now, boring is one of those things that can be a bit problematic, just because it's something you can't see and things behave a little differently. What you have to remember is that boring bars compared to turning tools are generally more flexible. So the first thing I'm going to do is do just a gentle pass, around about 1/10 thou depth of cut, just to clean the bore up from the drilling operation that I can use to measure from. I'm going to run that through twice, so I'll have a spring pass in there. Then I'll measure and work out what I need to take off. I've also adjusted it so my boring bar isn't sticking out any more than it really needs to, because the longer they stick out, the more they'll deflect, the more problems you'll get. So ideally, as soon as this hole is big enough for a larger bore, I would go for a bigger boring bar. As it is, this is the biggest I've got before it gets up to the size where I need to change over, but also the size of the motor spindle, so I'm stuck. My bore is now taken out to size. I think it's 5/8 on the dot, as far as I can tell. One trick I use for checking these things is that's the bushing out of my keyway set, and that just goes in, and so that means that that's pretty close to 5/8. Interesting enough, the first spring pass I took after my 1/10 thou depth of cut took off about 1 thou. The second cut I did, which was something like 20 thou depth of cut, the spring pass took off around about 3 or 4 thou. So spring passes are worth doing, and bit of WD-40 to help. I'm all done. It's starting to look like a pulley now. I've rough cut the steps, and one of the reasons for that is that if you have a heavy or largish piece of metal on a thin mandrel, it can tend to chatter a little bit, and so it's always a good idea to reduce the weight as much as you can. I'll now be putting that up, taking these to final size, putting the grooves in. I'll do that one by one so any cumulative error gets towards the end there, and then that'll be the motor pulley done, except for a keyway and a grub screw to hold on to it. I've now mounted my blank up on a mandrel. This is one of my, I guess you'd call it bolt-up mandrels. The shaft in the middle is 3/8. It's just got a thread, a washer, and a thread here, thick washer. If I can get this thing to rotate, there it is. Some of my mandrels I put a split pin, a roll pin or something like that in them, just so that I've got a positive stop against the jaws of the chuck. I've trued this up, and for this case it doesn't really matter, but if I was cutting a thread on something on here, for example, I don't want that slipping, and so to guard against that I usually have some form of stopping device. I've now grooved these 3 sheaves. The sequence of operations is basically take that down to size, do the grooves, move on to the next one. It's working quite nicely so far, so we'll just do one here to show you basically how it's done. I'm starting here with the tool against the what would you call it, the bottom of the previous one, because I'm relatively indexing, and that gives me a good starting point, a consistent starting point. These grooves are 10.8 millimeters, or these sheaves are 10.8 millimeters wide, and so I start there, I index in, I think it's 140 thou, and then 92 thou for each of the grooves. I go in 85. That'll depend on how your tool is ground, of course, but that's the theory. Here I am set up to cut the spindle pulley. I've got my roughed out aluminium disc mounted on an expanding mandrel, which, surprise, is being driven by a lathe dog. That was one of the reasons I made them, was that I knew this project was coming up. I'm getting a bit of a problem with chatter, and so I'm having to slow things right down, but that's to be expected. I've got a large weight hanging on a slender shaft, and it's going to bounce around a bit. So it's something to remember when doing this. If I didn't have the expanding mandrel, then I'd probably do as I did with the motor pulley and use a solid mandrel with a bolt or something like that. It'd achieve the same thing at the end of the day, keeping it centered. I wanted to try out the expanding mandrel though, because it's going to be key to doing the intermediate pulley when I get to do that. But for the moment, this isn't doing too badly. So I'll finish this off. That little step there is being kept on because it's in the original pulley. It's a bit of a spacer off the bearing, and so I'm leaving that a bit long, and I'll tune that once I've got everything sorted out. Similarly, on the back here, there needs to be a counterbore for the nut on the end of the spindle, and I'm leaving that until I find out where this is going to sit with respect to the other pulleys. I want to get the belt alignment straight, and then the counterbore will be sized to suit
generated
that.
So far by this project. But thanks for watching. Please share, and I'll be doing the intermediate pulley in another video.